Hi, Michelle Glass here. Welcome back to another episode in our Chapter 26, Lecture 26 series. We are still looking at pieces and parts of the nephron, and our job for today is to look at the distal convoluted tubule, which can be abbreviated as DCT. Now remember, we have traced the filtrate from the glomerular capsule into the proximal convoluted tubule, and we're going to call it tubular fluid at that point. From the PCT, the tubular fluid moves down the descending limb of the nephron loop, up the ascending limb, and then to the distal convoluted tubule. The job of the DCT is to secrete ions, acids, drugs, and toxins. Remember, secretion means moving it from the bloodstream into the kidney tubule so that it becomes part of the urine. So we're getting rid of it at that point. We also can see the selective reabsorption of sodium. This is under the control of the hormone aldosterone, and the selective reabsorption of calcium, which is under the control of the parathyroid hormone, abbreviated PTH. We talked about that as part of our discussion in AMP1 when we had our control of calcium conversation or regulation of calcium in AMP1. We also can see selective reabsorption of water at the DCT, and this is going to be under control of the hormone antidiuretic hormone, or ADH. So as we look at our DCT, it is going to be lined with simple cuboidal epithelial tissue, which we've seen other places in the nephron. Here at the DCT, those cells do not have microvilli like they had in the PCT, and so this is slowing down that reabsorption process. Also, we will see only about 15 to 20% of that original filtrate making its way to the DCT. So most of the water, nutrients, ions, and so forth have already been reabsorbed. In fact, 85% of water reabsorption happened in the PCT and the descending limb of the loop of Henle, or the nephron loop. Sorry about stumbling over my words there. That 85% of the water that's reabsorbed at the PCT and the descending limb of the loop of Henle is described as the obligatory water reabsorption, meaning that's always happening no matter the conditions in the body. As we move to the DCT, we're going to continue some reabsorption. So there will be a slow movement. Some of that sodium that's remaining will get reabsorbed back into the peritubular capillary. Same for chloride. And then here we'll see if you have the release of parathyroid hormone that you can reabsorb some calcium. So this is happening when those blood calcium levels are low. Otherwise, you don't get PTH, and the calcium is removed from the body with the urine. We said that 85% of the water has already been reabsorbed at the PCT and the descending limb of the nephron loop. And so we see that there's 15% of the water remaining that may or may not be reabsorbed. If that water is reabsorbed, we call that facultative water reabsorption. That's happening in the DCT under the control of the hormone antidiuretic hormone, or ADH. In the presence of ADH, the simple cuboidal cells will make aquaporins, which are special water channels to accelerate the movement of water into the peritubular capillary. So we'll see that water being reabsorbed. If you don't have ADH, then you don't get the facultative water reabsorption. You don't make those aquaporin channels. And so that water is just going to leave with the urine. So that's going to produce a large amount of dilute urine instead of a small concentrated urine. We have other secretion happening at the DCT. You are going to see these cells breaking down amino acids, producing ammonia and bicarbonate ion. So the bicarbonate ion will actually be reabsorbed. That's going to be an important body buffer. for the blood and other body fluids. The ammonia is going to be secreted with other waste materials. You also get the secretion of creatine, drugs, and other toxins at the DCT. And then we can have selective reabsorption of sodium and secretion of potassium. This is under the control of aldosterone. So aldosterone is a hormone we've talked about before. If you have the release of aldosterone, then we're going to have a sodium-potassium exchange happening here at the DCT. So sodium is reabsorbed and potassium is secreted. We also see aldosterone can turn on sodium hydrogen ion channels. So what we see happening here is in the presence of aldosterone, not only are we retaining our sodium, but we're secreting both potassium ions and hydrogen ions. So what we can see is regulation of potassium could lead to a pH imbalance, or regulation of pH might lead to a potassium imbalance, or just an excessive production of aldosterone might lead to both a pH and a potassium imbalance. So we'll be talking about that more in our next chapter. That's it for now.